Hey everyone, welcome to My channel. Today we're diving into Google's new Agent Development Kit, ADK, a powerful framework for creating multi-agent AI systems on Google Cloud. We'll walk through building a research assistant that leverages multiple specialized agents to analyze topics, retrieve information, and generate comprehensive reports. Google's ADK is an open-source Python framework designed to streamline the development, evaluation, and deployment of sophisticated AI agents. It allows developers to build systems where multiple agents can collaborate, reason, use tools, and interact naturally with users. ADK is tightly integrated with Google Cloud services, particularly Vertex AI and Gemini models, making it ideal for scalable enterprise applications. For this demo, we'll build a research assistant that processes a user's query through a team of specialized agents. Task Planner breaks down the research question into manageable subtasks. Retriever gathers relevant documents from the web. Summarizer synthesizes insights from the retrieved documents. Composer assembles the final comprehensive report. This modular approach mirrors a team of human researchers collaborating to produce a detailed analysis. Before we define our first agent, let's quickly talk about what makes an effective Elm agent. Building an effective Elm agent involves defining its identity, clearly guiding its behavior through instructions, and equipping it with the necessary tools and capabilities. With that in mind, let's define our query analyzer agent. Its role is to take a user's research question and break it down into 2 to 4 subtopics. Next, we define a search agent. This agent performs a web search to find relevant articles for each subtopic. It uses Google Search, an inbuilt tool provided by ADK. Once the search results are in, we need to summarize them. This is the role of the summarizer agent, which generates concise summaries from the search snippets. The final agent is the composer. It takes all the summaries and merges them into a well-structured final report. To bring it all together, we use a sequential agent. This special agent coordinates the workflow by running each sub-agent in order, starting with analysis, then search, summarization, and finally composition. It ensures each step smoothly passes its output to the next, automating the full research pipeline. Now that the agents are defined and orchestrated, it's time to run the app. Google ADK provides a built-in tool called ADK Web, which instantly spins up a demo UI for your agent. No extra setup needed. Just make sure you're in the parent directory of your project before running the command. This will launch a local interface where you can interact with your sequential agent and see the multi-agent workflow in action. Once you run the app, you'll see a chat interface open up in your browser. This is the ADK Web UI. The UI is split into 2 main sections. On the left, you'll find the developer panel showing real-time insights like event logs, agent states, session info, and evaluation. This section is incredibly helpful for understanding what each agent is doing under the hood. On the right, there's the chat interface where users can submit queries and interact with the system. Let's try it out by asking a question. Give me the latest update of Google I/O 2025. This query is sent directly to our coordinator agent, the sequential agent, which routes it step by step through each sub-agent. First, the query analyzer breaks down the question into subtopics. Next, the search agent uses the Google Search tool to find information for each subtopic. Then the summarizer agent condenses those findings into a clear summary. Finally, the composer agent turns it into a polished, structured report. Click on Trace in the left panel to inspect each agent's performance, including input, output, and latency. This makes it super easy to debug, analyze, and see how each agent are collaborating in your multi-agent system. In final output, you can see a well-organized document titled Google I/O 2025, a comprehensive update, covering everything from key announcements to technologies like Android XR and Gemini AI. ADK offers advanced capabilities. Agent-to-agent, A2A, protocol enables standardized communication between agents, facilitating complex workflows. Model Context Protocol, MCP, allows agents to access shared context and tools, enhancing collaboration. Integration with various LLMs supports models like Gemini, GPT-4, and Claude via Light LLM. These features empower developers to build sophisticated, interoperable AI systems. We've built a multi-agent research assistant using Google's ADK, showcasing the power of modular AI systems. If you found this tutorial helpful, please like, subscribe, and share. Have questions or suggestions? Drop them in the comments below.